Hi, I'm Rebecca Joan Brown, and welcome to the fourth installation of Green Building Research Institute's Case Study Series, Lessons Learned from 99 LEED Projects. Lessons Learned from 99 LEED Projects is a six-part series where we dissect 99 LEED Gold and Platinum certified projects to identify what strategies work best in each of the 6 LEED categories. We will be looking at the most frequently applied strategies, those that are easiest to implement, and at some of the interventions that stand out as especially unique or elegant solutions. Today's presentation focuses on energy and atmosphere. Today's course will focus on providing an overview of the energy and atmosphere credits available to projects in the 3 largest LEED rating systems, BD&C, ID&C, and O&M. We will look at the requirements for each of these credits and suggest solutions that were common in the 99 projects that we studied. We will also profile projects that showed exceptional dedication to their energy goals and earned some of the highest scores for the EA section. Energy use and the release of atmospheric contaminants is one of the most critical ways that green buildings differ from conventional ones. Conventional buildings rely on traditional energy sources that are heavily subsidized and therefore cheaper for the end user, although quite expensive for taxpayers as a whole. Green buildings explore all options for building energy and work to craft an energy portfolio that includes renewable and less harmful energy sources. As a part of their energy strategy, green buildings address the release of ozone-depleting products and greenhouse gases. A green building project will make reducing these emissions, both through their choice of energy sources and as a part of building function, a primary goal. This consideration is not often applied to conventional building projects beyond lawful requirements. Conventional building abides by any local or national codes that govern energy efficiency. However, building cheaply is often given higher priority than creating an energy-efficient building. Green building practice looks at the lifetime performance of a building and its total environmental impact and operational expenses. Looking at efficiency in the long term may increase upfront costs slightly, but will almost always pay off in reduced operational costs over the life of the building. Here you can see the chart that sets the energy thresholds for buildings to earn the credit points for the energy simulation option. As you can see, compliance levels are different for new versus existing projects, and the points awarded to core and shell projects are higher than those awarded to new construction or school projects. As you can see from the column at right, many of the projects that we reviewed were significantly more efficient than the ASHRAE baseline. Energy efficiency is popular in the building market, both from an environmental standpoint and from a return on investment perspective. Decreasing a building's energy costs is one of the strongest ways to reduce costs of operating a building in the long run, and is especially attractive to building owners as energy prices are expected to continue to rise for the foreseeable future. Listed here are some of the more common strategies that projects can use to maximize energy efficiency. A building's shape and orientation can affect the energy load significantly. Placing the primary axis going east-west will allow ample light on the north and south faces of the building. With correct glazing strategies, this can significantly reduce the need for artificial lighting and can be used for passive solar heating in some instances. It's also a good idea to consider the natural resources available on site. This could again include solar exposure for light and heat, but also includes other resources, such as wind that can be used for passive ventilation strategies to reduce HVAC loads. Solar exposure may also be used to generate power or for solar water heaters and other specific installations. A more efficient building envelope will reduce thermal transference, also reducing HVAC loads. We will discuss efficient lighting strategies and HVAC efficiency in the coming slides, but it's important to note that these are the 2 primary consumers of building energy, so increasing efficiency in these 2 building components will have a significant impact on overall building performance. Finally, As an example of an ID&C case study, we turn to the USGBC headquarters project in Washington, D.C. As the predominant voice in the sustainable design and construction, the organization had a lot to live up to with its new office space. The project was able to earn 94 points overall, giving it platinum certification, and earned 36 out of 37 points available in the energy and atmosphere category. Again, the project tackled two of the largest building energy users, lighting and HVAC, and was able to reduce overall energy use to 50% below the average for a project of its scale. Lighting was addressed by making use of the floor-to-ceiling windows that were already a part of the project space, and arranging the interior configuration to make best use of the natural light provided. In the main workspace, desks and workstations were moved to the center, and interior partitions were removed. This not only allowed light to diffuse as it reached all workstations, but also erased office hierarchies by providing both everyone and no one with a window. Automatic shading devices are used to minimize glare, and the perimeter area that's used for circulation uses light-colored carpeting to help reflect daylight. A universal control system uses photo and occupancy sensors to adjust the fluorescent lighting levels and temperature in response to space conditions. All of these interventions, as well as the use of efficient lighting fixtures, gives the space a lighting power density of only half a watt per square foot, which is 52% below the ASHRAE thresholds.